So starting our rotational motion unit, the first thing that we really need to talk about is the way that we measure basic rotation, which is either with radians, degrees, or revolutions. So let's start with the one that really doesn't require humans at all. Let's talk about what radians are. So to start our discussion of radians, let's talk about a quarter. A quarter has um, a diameter of 24.26 millimeters, approximately. And if you measure the circumference around the outside, like with a piece of string or something like that, we can find out that its circumference has a measure circumference. Here we go. The circumference is 76.21 millimeters. So if we divide the diameter, if we divide the circumference over the diameter, we get this number, 3.141 approximately. First thing to mention is that number is actually unitless. Since this was millimeters over millimeters, the units just canceled, and we got the value 3.141. That's what I got with this, and obviously there's limits to how accurate it is because of how well I can measure the diameter and circumference. But it turns out that with every single circle that you ever measure, if you compare the circumference to the diameter, you always get this number, 3.14 something. It doesn't matter how you measure it. If we measure it in inches, we get 3.14. If I measured it in hand lengths, I'd have to have like a bigger circle, like maybe a tire. But as long as you're consistent within the tolerances of your accuracy of measurement, you always get this value, 3.14. This is not a number that's made up by humans at all. This is a fundamental constant. Of course, you guys know what it is. The fundamental unit constant pi that relates all circles, the circumference to their diameter. I hope you take a moment to think about how weird that is, that every single circle and every single diameter have this relationship. I remember I was reading a book at one point, and in the book it was a sci-fi book, and in order to explain how incredibly weird some alien technology was, they measured the outside of these circles on the alien ship and found that their circumference was 3 times the diameter. Um, which broke my brain when I first read about that because I was trying to imagine how something like that would work. And according to not physics, but the very relationships of our universe, it wouldn't work. So, I mean, it was a book. That's pi. Now, if we took one circumference, a circumference could also be written as 2 pi r. If we only wanted to do like half of a circle, 1/2 of a circle, then it would be pi times r, would be like the length around the outside. If instead we only wanted to do a quarter of a circle, so we only wanted to do, say, this much, then it would be pi over 2 times r. So actually what starts coming out of this pattern is we can see that there's some kind of relationship between these leading values here and between how much of a circle we get. So we can actually break this down a little bit and say describe circles in terms of how much of a circle this part makes. So 2 pi is a whole circle. Pi is half of a circle. Pi over 2 is a quarter of a circle. And depending on how many fractions of pi we want to deal with, we can talk about how much of a circle we have. So this is the idea of a radian. A radian is a measure of how much of a pi or how much of the value pi you've moved around relative to the radius and circumference. So it's a useful measurement that is unitless. If we talk about something in terms of like it's 5 radians, it's not really 5 radians. It's 5 relationships between circumference and diameters, but it doesn't. The meters, the inches, whatever, all those things, they don't matter. So we will be writing radians in, but as we get deeper into this unit, you'll see that very often we get to a certain point in some of our calculations that we just like pretend that radians don't exist anymore. We're not cheating when we do that. We're just using radians as a placeholder for units and then getting rid of them a little bit later on. So that's where radians came from. And if we want to talk about another way of measuring angles, we can talk about degrees. Degrees are probably a little bit more familiar to you guys. Um, I mean, I'm sure radians are as well because you guys have done them in your math class. But degrees you've probably been dealing with for a lot longer. Degrees are actually really old. The degrees kind of come from Mesopotamian history. In Mesopotamia, they had a base 60 counting system. Base 60 is interesting because what you do is you count to 12 on one hand. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You're using your thumb to count the number of, I don't know, whatever you call these, spacers on your finger, spaces on your finger. So there's 12 on one hand, and you count how many dozens you have on this hand. So you can get up to 5 dozen plus another 12 on this hand for a total of 60. So base 60 was useful to them because it's very easy to divide, even for somebody who doesn't have a ton of math experience. You divide in half and thirds and quarters and even twelfths, tenths and twelfths really quickly. But the Egyptians took it one step further and they did 6 60s for a circle to give a circle a total of 360 degrees. So 360 degrees is a circle. That's probably not a big surprise to you. And then the last thing that we can talk about is we can talk about revolutions. And pretty much we give credit for revolutions to the French. So one revolution would be all the way around a circle, which would be exactly 360 degrees or 2 pi radians. Half of a revolution, that would be 180 degrees. That would be pi radians. A quarter of the way around a circle, that would be 90 degrees. And that would be pi over 2. If we wanted to do something like 60 degrees or 45 degrees, 60 degrees would be exactly 1/6 of the way around. So 1/6 of a revolution or pi over 3. And then 45 degrees is pi over 4, or it's 1/8 of the way around. So there's lots of different relationships. We will tend to use, in this particular unit, radians. But the reason why I'm emphasizing the relationship between these is that revolutions and degrees show up here and there as well. So when we're doing rotational motion, we'll be mostly using radians, but don't be surprised if you see degrees and revolutions every once in a while. If you need to convert between them, the conversions work that if you take a revolution and you multiply by 2 pi, that will tell you how many radians you have. Going back the other way, if you want to turn radians into numbers of revolutions, you would divide or multiply by 1 over 2 pi or something like that. If you're trying to go from revolutions to degrees, you multiply by 360. If you're trying to go from degrees to revolutions, you would, of course, divide by 360. Finally, if you're trying to go from degrees to radians, this is probably the trickiest one that we have. And this is where you would multiply by pi over 180. And then if you're trying to go from radians to degrees, you would multiply by 180 over pi. I guess the very, very last thing to mention here is the variable that we tend to use to represent angular displacement, the thing that has these units. And then we're going to be using this unit that you guys, or this variable you guys have seen quite a few times already this year. We'll use the Greek symbol theta to represent our angles. But theta could be in revolutions, degrees, or radians, depending on the problem. So that is all the stuff you need to know about radians, degrees, revolutions. Thanks.